Hello, welcome to Econometrics Melody. In this video, we'll discuss about the variance of a random variable. And first of all, let us see what is the random variable. So we carry out a random experiment, and based on all the possible outcomes of the random experiment, we create a random variable called x, and it takes a certain numerical values, and we assign the probability based on certain feature of all the outcomes of the random experiment. If we add all the possible probabilities, that should be equal to 1, and based on this x along with its probability, we can always calculate the mean. And if we calculate the mean, then we call it is the expected value of this random variable x. And the formula to calculate the mean, we have already seen it. First of all, we calculate the product of the probability and the observations for all observations from 1 to n. That is what we mean by the expected value of that random variable x. Now in this video we are talking about the variance. So variance of x, this is equal to, for each observation we take the deviation from its expected value, and then we take its square, and we take the product of this term with the probability, and we sum this for all the observations from 1 to n. So this is the variance for our discrete random variable. Similarly, for the continuous random variable, we integrate the product of square of deviation from mean and the probability density function. Then this is equivalent to expectation of this x. So here x, it is our xi minus expected x whole square. Now let us expand it. So this is equal to the expectation of, it is a minus b whole square, a square minus twice a b plus b square, expectation of x and its square. So let me write it in this way. It is expectation of x square minus twice this twice, and here expectation of x, this is some sort of constant, it is constant, and we are left with this x. So it is expectation of x plus, here expectation of x, it is itself constant, the expectation of any constant that should be equal to the constant itself. So we are writing the value, only the constant value and its square. We have twice expectation of x and its square again. So twice this thing plus this the same thing. So if we operate it, we are left with 1 times that thing. So this is what we mean by the variance of x. Here x is our random variable, so please don't confuse with this x and this x over here. They are same, they are one and the same. So the first one, this one is the generic formula to calculate the variance of x, and when we expand it, so this is our second formula to calculate the variance of x. So this is the generic formula to calculate the variance for random variable x in case of discrete random variable, and this one is for the continuous random variable, and this one is for the random variable represented in terms of expectation, and this second one is the expanded version of this first one. And now let us see some important property. So we have a random variable x, and let us scale it by a and shift its origin by b, and this should be equal to another random variable. Let us call it as y. We have already seen that if this is true, then the expectation of y, this should be equal to a expectation of x plus expectation of b is b, because the expectation of constant is the constant itself. So this indicates that if a random variable y undergoes this scaling of x and shifting in origin by this unit, then their expectation also follows the same scale and same shift in the origin. Now from these two, let us subtract them together. So let us square them, y minus expectation of y, and if we take its square, so we are left with, first of all, let us take the common, ax minus expectation of x, and then its, as we have squared our left hand side, so this is equal to a squaring of this. Now let us take the expectation on both the sides, so we are left with is equals to, so a is constant, this is a square, and then expectation of, if we compare it with our previous formula, so this is equal to the variance of y, this is equal to a square, and then variance of x, for the sake of comparison, so let me write it once again. Here our y is the function of our random variable x. So given this construction of the random variable y, the expectation also follows the same scale and the shift in origin, while the variance, it is proportional to the square of the scale, but the shift in origin, it does not matter while calculating the variance. So this is referring that the variance of the constant is equals to 0. So let us say if a random variable k, expectation of k should be equal to 5, because we are taking 25% of 5 4 times, and that should be equal to 5 itself. But its variance, so we don't see any change over here. It is very intuitive. There is no variation at all. So the variance of this random variable k should be equal to 0. And another implication is that, let us say we have a random variable called m. Then if we add or subtract some constant from all of these observations d, then the variance for these new observations attained after adding or subtracting this new constant d, that won't change. This new is n, and then in that case variance of n should be equal to variance of m. But instead, if we multiply the observations by certain constant, then in that case variance of n should be equal to d square the variance of m. This is what this formula is referring to. So this is it for this tutorial. Thank you very much for your time. Thank you very much, Econometrics Melody.